Okay, so what is calculus? According to MIT, calculus can be defined as a branch of mathematics that deals with the properties of derivatives and integrals of functions.
As a group of civil and construction engineers and environmental scientists, calculus gives us the ability to create and control systems as well as models during the research, design, and manufacturing process.
We use calculus as support for the laws of nature. Calculus can also be considered as a language of physical science and engineering. Knowledge of traditional mathematical analysis is essential for methods of validation.
So what are we doing? We are designing and constructing a bridge and using local extrema to figure out how high the tension cable must be from the ground in order to ensure sustainability. Our number one priority is to ensure safety for all uses and having the goal of maximizing efficiency, which is done by making structures more stable with fewer materials.
In the erection of a suspension bridge, the key parts to keep in mind are the footings, the columns, the concrete slabs, and the suspension cables, also known as pylons. All these key parts play a role in reinforcing the bridge and maintaining equilibrium. Using the concept of local extrema, we're going to find the height of the tension cables above the surface of the road. The forces acting on the cables indicate both the magnitude and the direction of the forces being placed on the structure. Once we know the direction of the forces acting on the bridge, our group of engineers can then determine the factors of safety necessary to maintain serviceability.
But wait, I'm stuck.
What do you mean you're stuck? Extrema only occur at critical values or endpoints. So all you have to do is find the critical values by taking the first derivative of the function, then finding the values where the derivative is equal to 0 or does not exist.
Make sure those values in the domain.
Of course. Then all you have to do is plug the critical values that you found into the original equation to find the exact point of the extreme.
So the equation that we're going to use is 4x squared plus 6. Like stated before, your first step is going to be to find the derivative of the function. So your derivative is going to be 4 multiplied by 2, x plus 0, and then you can break this down even more. So your derivative is going to be equal to 8x. Your next step is then going to be to set the derivative equal to 0 and solve for x. After you found your x value, you're going to plug that back into the original equation. And then you're going to solve. Since I found my value to be equal to 6, this is now your absolute minimum.
From the absolute minimum value, we can conclude that the tension cord must be 6 kilometers above the surface of the road in order to ensure stability of the structure. By guaranteeing stability, we also achieve our original goal of maximum efficiency and safety.